ये हमारा मार्च 2024 पेपर है, इसको हम जस्ट क्विकली करेंगे, ठीक है, क्योंकि हम जस्ट फार्मूलाज को देखेंगे, वी डू नॉट शो द सॉल्व कैलकुलेशंस। ओके
Yes.
ओके So first is about telling about base quantities. So these two are base quantities. Next, define definition of the power. Tell the SI base units for power. So simply you will do work done per unit time. Work done has unit Newton meter and time has second and Newton has kilogram meter per second square. So you will simplify it and you will get the answer. Okay.
Yes.
In next part, the area is given and intense. Sorry, power is given and we have to find the calculate the power. We have to find power. So simply power is equal to intensity time area. So from intensity for intensity you have power per unit area. Oh sorry, power per unit area. So from this relation we are using this one. Okay.
Yes.
Next question. Here is defined acceleration, simply rate of change of velocity. Next, here is a person is standing and his initial velocity is 5.9 meter per second. Angle at 60 degree. Now he dives. The height of water is 9 meter. The his height from he dive is 9 meter and uh, now his new position is 1.2 meter. Okay, air resistance is negligible. Calculate the speed of the driver at instant when he hits the ground. So we have given energy and we also have we have to find velocity here. So we will use kinetic energy equal to potential energy. So m will be cancelled on both sides and 2 will be multiplied on other side and for velocity we will take the square root of it. Okay.
Yes.
Okay. This is the right speed.
Yes.
Okay, next part. Next variation in the viscous drag force acting on the diver in the water as he moves downward. So simply viscous drag force decrease. Why? Because as the diver moves down, the speed decrease. So as he is moving in the water, so its speed decrease, and eventually the viscous force also decrease. If speed increase, then viscous force increase. Okay. Next part.
Yes.
The volume of diver is given. The density of water is given and what thing is given upthrust is also given. Okay, and here we have and we have to find the value of upthrust. So simply you will use formula for upthrust. Which formula?
Rho GV.
Yeah, so simply you will use this formula. Next part. Next part, uh, force is given, upthrust are 950 Newton is given, which is acting upward. The mass is given. Okay, determine the magnitude and the direction of the acceleration for diver. So here we have to find the magnitude of acceleration. So initially we have upthrust, and now this is another force is given, and both forces are in same direction. So you will just add up these two forces, and you will subtract weight from it. Okay,
Yes.
these arrowheads show the direction. Mean arrowhead for up thrust is upward and for drag force is also upward. And for weight, arrowhead is downward. Mean it's acting downward. So simply you will add and then subtract. Then here you will get a resultant force. And for acceleration, mass is given in the question. So you will use the Newton second law. F is equal to ma, and from this relation you can find the value of acceleration. Have you got it?
Yes.
Next question. A model planet is connected with a wire as shown in the figure, and its stress and strain. Stress versus strain is given in this figure. Okay, here you have to tell the strain in x is for mean strain is given. Okay, calculate the force exerted on the wire by the model planet. You have to find the force. So you have stress and strain. So for stress you have force per unit area, and here you have wire. So for wire, first you will find the area, which area is equal to pi r square, and here the diameter of the wire is given. So you will take half of it for r, and then you will be able to find the area. So area comes here, this one. So this is your area, and now you will use this area in this formula to calculate force. So it will be stress times area. So stress is given in the question. So you will just multiply it for here. Here the strain is given, and you will find it. You will find the stress related or associated with this strain. Have you got it?
Yes.
Then you will use that value from graph and you will multiply it with the area, and it will give you the value of force. Okay.
Yes.
Next is elastic potential energy is given and calculate the original length of the wire before the model planet was attached. So we have to calculate original length. So you will use elastic potential energy is equal to half Fx. So for strain or for length, you will use the formula of strain. Strain is equal to change in length over original length. Okay. So from this relation, you can find the original length, and then you will use it to find sorry uh, from elastic potential energy formula, first you will find the extension. Okay, then you will use this relation L is equal to E times T over strain, and it will give you the original length. Means simply, you should remember whenever you are talking with stress string or Hooke's law or stress strain, then you should remember these three formulas: half Fx and energy is equal to half Kx square. This is the second one, and third one is equal to F is equal to Kx, which is Hooke's law, and also stress is equal to force per unit area. Strain is equal to strain denoted by small e. It is equal to change in length over original length, and Young's modulus is stress over strain. So whenever you are solving the question related to stress and strain or stretch, then you should keep in mind all these relations. Is it okay?
Yes, sir.
So all these relationship okay for you, easy or not fun?
Sure. Easy, sir.
Okay, okay. So in the next part, draw the line representing the variation for mean. In the next question, now the what thing has changed? Diameter of the wire has changed. So with the diameter of change, you have to draw new line. So it's also simple question. Next question, it is about decay, alpha decay, beta decay. So here an alpha decay happens, and he is asking about the nucleon number and proton number or charge number. So these questions are also simple one. Next part, moment before decay, the speed is given. Okay, calculate the speed of the alpha particle after the decay. So you have to here you will use the momentum before and momentum after decay. Momentum before decay and momentum after decay. Is it okay?
Yes.
Whenever you are solving with momentum, you should keep one thing in mind, that you should consider the direction of velocity. One thing, because sometimes it comes positive, sometimes it comes negative due to opposite direction. Okay. So
Yes, sir.
whenever you are dealing with momentum, then you should keep in mind the sign for velocity. Okay.
Yes.
uh, okay, so in this part we will use the law of conservation of momentum. Next question is about propagation energy. Yes. Uh, next, here's about this topic. This question is about waves. So there are two types of wave: progressive wave and progressive wave are two types. Further, transfer wave and longitudinal wave. In transfer wave transfer the energy, while the longitudinal wave do not transfer energy. And other difference is that in transfer wave, particle vibrate perpendicular to the direction of the propagation of energy, while in longitudinal wave, both move in parallel direction. Is it okay?
Yes, sir.
Okay, then next part is about waves. So whenever you are dealing with waves, then you should remember this formula: V is equal to F lambda, where V is the speed of the wave, F is the frequency, lambda is wavelength. And also remember this one, that F is always equal to 1 over T. Okay, mean
Yes, sir.
frequency is inversely proportional to the time period. So you should just remember formula, and this formula is being used here. Okay, in the next part, it's an experiment or diffraction grating. So for diffraction grating, you should remember this formula: lambda is equal to ax
AX over
over
D.
d. What is a? A is slit spacing. Okay, slit spacing. What is x? X is fringe spacing. Fringe spacing. Okay, and what is d?
Yes. Distance
Yes, uh, distance of which thing?
from the slit to the fringe.
Yes, select to screen, not French. Select to screen. Okay, screen on where you are getting the French. Okay, Okay, in the next question, this is about stationary waves. So whenever you are talking about stationary wave, you should keep this thing one thing in mind that uh, two stationary wave have one wavelength. Is it okay? Mean two
Yes,
stationary
sir.
waves always equal to one lambda, or you simply call it L. So you should keep these things in mind. Next is in phase, mean the points on a wave which are at same phase or are in phase. And next is nodes and antinodes. The nodes are the points where there is no displacement or no amplitude, and antinodes are the point. But always remember, the node and antinode always belong to stationary waves. Is it okay?
Yes, sir.
Okay. So next next is about the potential difference or electromotive forces.
Wait,
So
sir, 1 second. Can you go back to the previous question?
this question.
Yeah.
Okay, have you any question here?
Sir, how will this part where new fringes will be closer, for example, fringe spacing will decrease? How?
In which part? In above part.
Yeah.
Simply, you should always use that formula. Lambda is equal to ax over d. Okay.
Yes.
Now in the question it states that a remains same, d remains same, and in most of the question these two things remain same. So here you can see that lambda is proportional to x. Mean it directly relates with x. So when the lambda increase, then French spacing increase. When lambda decrease, French spacing decrease. Have you got it?
Yes, sir.
Okay. So is it clear with this question?
Yes, sir.
Okay. Next is here you will use Kirchhoff's law. You can use you should here you should remember the Kirchhoff's law. Kirchhoff's current law, which is equal to I is equal to current into junction is equal to current out of junction. Okay. And what is
Yes.
Kirchhoff Volt's law?
Um. Uh. E is equal to V plus IR.
Yes, is equal V plus IR. Okay. No, that's not, that is with related with internal resistance. Actually, algebraic sum of all the electromotive forces and potential difference in a closed circuit must be zero. This is a statement of Kirchhoff's second law. Okay.
Which one,
Me
sir?
algebraic sum of all the electromotive forces and potential differences across a resistor in a closed circuit must be zero. Okay.
Yes, sir.
Okay. So and other thing you should remember Ohm's law, which is V is equal to IR. And other thing, when the resistors are in parallel, then you should use this formula to calculate total resistance, which is R1 plus R2. Oh, sorry, when this is for in series, and when you have resistor in parallel, then you will use this relation: 1 over R is equal to 1 over R1 plus 1 over R2. Is it okay?
Yes.
Okay, and other thing which arises in these questions, are you seeing on screen, is that about calculate the potential difference across a specific resistor. And for that, what you will do, you will take that value V for that specific resistance, and here you will do just multiply E. E is the electromotive force of the battery, and multiply it with that specific resistance. Let me call it R. Okay, so you will multiply the resistance with electromotive force across its ends. You are calculating potential difference, and on denominator you will just add up the other resistance. Okay,
Yes, sir.
let me call it Rx, and other one Ry. So you should also remember this formula for calculating potential difference across a resistor. Okay.
Yes, sir.
And other thing, when the internal resistance of the battery plays its role, then you should keep in mind this relation: E is equal to V plus IR. V is the potential difference across terminals, and IR is the potential across internal resistance. Okay,
Yes.
so all these are the relations which are you seen on screen. All these are relations with related to such problems. Okay,
Yes, sir.
okay. Next part is again, next here is talking about different effects. Okay, now we move to next. Next is about fundamental particles. So they are hadrons and mesons. So for up quark, you have always you will use 1/3 charge. For down, you will use minus 1/3 charge. Okay,
Yes, sir.
so whenever a beta negative decay happens, an electron and antineutrino comes out as a product or as a daughter. Okay, and whenever beta positive decay, then a proton and neutrino, neutrino or antineutrino in beta plus decay.
Beta plus decay is a neutrino.
Yes, it's neutrino. Okay, so in beta plus decay you get neutrino, and in beta negative decay you get electron and an antineutrino. Okay.
Yes,
So now we are going to do next see another paper. It's November 2023. Okay, we will also do it quickly. First question always coming out from base quantities and drive quantities. Okay, and they are SI units. So there are actually seven base quantities. Can you repeat them?
there is current,
Okay, one,
temperature,
two,
distance,
length or distance. Okay, three,
mass.
four, amount of charge, amount of substance, mole,
Oh, oh yeah, mole, and there's one more, sir.
and one left, which is you have skipped time. Okay,
Oh yeah, time.
okay. So, so these questions comes here. Okay, what are the equations of motions? One is S is equal to VT. Can you tell for other equations of motions?
S is equal to ut plus half at squared,
Yes, S is equal to UT plus half AT square. Okay, and other one.
and then v squared is equal to u squared plus 2as.
Yes, V square is equal to U square plus 2AS. Okay,
S equals u plus at.
S is equal to U plus AT. So almost these
Uh,
are okay. So whenever you are talking about acceleration, whenever you have given acceleration, you have to find distance, height. Then most of the in the most of the paper we use this equation which I have underscored. Okay, and whenever you
yes,
have acceleration, distance, and you have to find velocity or speed, then you will use this one, which I have made it with correct text sign. Okay, and whenever you
yes,
simply are given time and velocity, then you will use this simple one, s is equal to vt. Okay,
yes.
okay. One thing, remember one thing. One question also comes that is about for uncertainties. So whenever you have percentage uncertainties, what you will do with them when you are adding, sorry, when you are dividing or multiplying the things, quantities.
You added the percentage of
Yes,
uncertainty.
and what if you have power of some variable?
You multiply by the power.
Yes, so you should also remember this thing. Okay, and what is about the area under velocity time graph?
The under velocity time graph is distance.
Yes, it's distance. Okay, and what about gradient of velocity time graph?
Acceleration.
Yes, it's acceleration. Okay, now move next. Mm, no, I am not seeing the question. I am just seeing the concepts. Whenever a new concept, I am just revising it. Okay.
Yes, sir.
I think it's more better thing than to see the questions. So yes,
Yes.
here again for upthrust force. One thing more. What formula you will use for pressure with depth, or when an object is at some depth in a liquid?
Pressure is equal to rho GH.
Yes, rho g hat. Okay, very good. Okay. So okay, what is formula for work done?
Work done is equal to force times distance.
Yes, okay. And then what is formula for power?
Work done over time or energy over time.
Yes, work over time. In the most cases, you can use energy over time. Okay. Then what is formula for pressure?
Force over area.
Yes, it's force over area. So In most questions, we have all done all these with relations. Okay, in most of the past papers. So now next, if anything's come new here, nothing new. Yes, Newton's second law, simply F is equal to ma. Okay. So another thing, what about if the velocity is not changing? If there exists acceleration exists or not? If the velocity is
There will
not
be
changing,
no acceleration.
yes, there will be no acceleration. Okay, very good. And again here, again these are the related to elastic potential energy, kinetic energy, Hooke's law, same things. Okay, so one thing,
Yes.
what is the law of conservation of kinetic energy?
Um, Kinetic energy is equal to before plus
Yes,
after.
kinetic energy before must be equal to kinetic energy after. Is it okay?
Yes.
Okay, one thing more. From this, we have deduced one thing that the velocities, sum of velocities before must be equal to sum of the velocities after. Okay, so
Yes.
from law of conservation of energy, you can also deduce this thing. That's the velocity before collision must be equal to velocities after collision. Okay,
Yes, sir.
okay. Next, what about mm, principle of moments? Yes, we till now we have skipped this part. What about principle of moments?
Uh, moment. So
First, tell
for
me
our
what is
thing to be
moment?
in
What is the formula for moment?
it is uh, the force in the direction. No, the distance in the direction of the force.
No, no, then it's work.
Oh yeah, yeah.
Force opposite to force at 90 angle at some angle with oh sorry distance. Okay, or FD sine of theta. You can use this one. In work done, you use FD cos of theta. Okay.
Yes, sir.
Whenever you have work done, you take cos of theta, and whenever you have when are you talking about moments, then you take sine of theta. Okay.
Yes, sir.
And what about this d, what you call when are you are dealing with moment, then what you call this distance, what is the name for this d or r,
Perpendicular distance.
and what is its name? Moment arm. Have you got it?
Yes, sir.
Next is what are the law of moments?
Anti-clockwise moment is equal to clockwise moment.
Yes, anti-clockwise are equal to clockwise. Okay. नेक्स्ट अभी एक चीज मेरे माइंड में आई थी, वो फिर से निकल गई है। वो भी आपको बताने वाली थी, पता नहीं कौन सी थी। बड़ी इंपॉर्टेंट चीज थी, इसी से रिलेटेड थी। चलें, फिर माइंड में आ जाएगी दोबारा। अच्छा, अब देखें, आगे देखते हैं। दिस इज अगेन फ्रॉम of our law of conservation of momentum. So momentum before and momentum after collision. So same thing. Okay, and then next here, what is here? During the collision. Okay, this is all about collision. Mm, yes, here we have used that one, which I told you, the law of that the relation which we deduced from law of conservation of kinetic energy. Here you can see that you have just added up the velocities. Velocities before equal to velocities after. Okay,
Yes, sir.
okay. See next. Yes, this is one about Muller's law about intensity. So, what about intensity? Transmitted intensity and incident intensity. It has this relation: I is equal to I naught, or original intensity cos. Yes, I naught cos square of theta. Is it okay?
Yes, sir.
So, another thing, what is the relation between velocity and amplitude? Oh, sorry, intensity and amplitude. Sorry, not velocity. Intensity and amplitude. Intensity is proportional to the square of the amplitude. Okay.
Yes, sir.
Okay. Yes, one thing which I got remember that what formula you can use for path difference. So path difference is equal to n lambda in case of or you can use d sine of theta. Is it okay? And lambda equal to d sine of theta. And here n is the number of order. Okay.
Yes, sir.
Okay. What about what is the path difference for constructive interference?
For constructive interference,
Yes,
it is a
in form of lambda.
whole number.
Yes, in form of yes, one lambda, two lambda, three lambda. Okay.
3 lambda.
Yes, okay. And what about for destructive interference?
It's 3 lambda over 2.
Yes, R5 mean a half integral multiple. Okay, half integral.
Yes.
Okay. One thing we have missed that Doppler effect. So Doppler, what is Doppler effect? Because okay, I think it's not in question, but here I have come in mind. So just I am telling you that here, if you have a source and it is emitting the sound, okay, and here you have an observer, okay, the source have some frequency which is fs, okay, and this sound has speed v, okay, and here is the observer. He is observing this sound, and now the frequency observed by this observer is f naught, and the speed with which the sound reach to this person is Vs. Okay, then you
Yes.
will use this formula for Fo equal to Fs Fs into V over V plus Vs. Or if the source is moving away and if the source is moving towards him, then you will use this formula F naught is equal to Fs V over V minus Vs. Okay, this is
Yes, sir.
about from Doppler effect. Okay. Next, same thing we have discussed in above part that part difference is always equal to n lambda r d sine theta. Okay. This thing we have missed. That resistance is have this formula relationship. Resistance is equal to rho L over A, where rho is the resistivity, L is length, A is the area. Okay. Hello.
Yes. Yes,
Okay.
yes.
Okay. So what is LDR?
Uh, Light dependent resistor.
Okay. What is formula for current?
Current is equal to V, so use V equals IR or
Nani
uh,
in form of charge. If you have
in form
charges,
of charge.
yes, if you have charge and time,
Q equals IT, so I equals Q over T.
yes, q over t. And if you have more number of charges, then you will use it n q over t. Okay, n mean number of the charges. Okay,
Yes.
okay. See next, what is here? It's about yes, about calculating the potential difference across a specific resistor. So we have done this thing. The three formulas for power. Can you repeat these three formulas?
P equals IV,
Okay,
P equals V squared over R,
v squared over r. Okay,
and P is equal to I squared R.
very good. I squared. Okay. So these three formulas are related with P. Okay. Next is again from wave topic, again from fundamental particles. So we have discussed these things. So we have discussed all this paper. Okay. Now we are moving
Yes.
to next paper. Okay. Now we will go with this paper. Again, it's from pressure. So formula for pressure, base units for pressure. Okay, and then base units for other quantities. This is about for percentage uncertainties. We have discussed this thing, and again here for law of conservation of moments. Okay, so we have also discussed this thing. Okay, next, if anything, yes, projectile motion. So here about for projectile motion, but in case you have not to find the range or difficult formula for projectile motion. So for projectile motion, you will use just about you will just use the equation of motion, okay,
Yes,
and you
sir.
will be able to solve the problems. So again, yes, one thing, law of conservation of energy mean the loss in kinetic energy is equal to gain in kinetic energy. Okay.
Yes, sir.
Yes, and other thing, horizontal component and vertical component of the velocity. So these are simple things, you can do it by yourself. Next is again resultant force. Hmm, Next here, what is change in momentum? So momentum is equal to P is equal to mv. So you should remember this formula: P is equal to mv. And what is the relationship between momentum and force? So for force is equal to change in momentum per unit time. Okay,
Yes, sir.
or simply you can call it the force of collision. Okay, this thing also. One thing more. For power, I have remembered this thing, that for power you can use this formula: P is equal to FV. Okay, where F is the force
Yeah.
and V is the volume. Okay,
Yes.
okay, then we are also do this thing, then this thing. Okay, F is equal to Kx. Okay, Hooke's law, nothing new. Again, elastic potential energy or strain energy. Remember one thing: elastic potential energy is similar to the strain energy. Okay,
Yes, sir.
and here is again transfer wave and longitudinal waves. Okay, we have discussed this thing here about stationary waves. So for stationary wave, lambda must be equal to L, and if you have more length wavelengths, then this lambda increase 1 by 2, 3 by 2, 5 by 2, or 2 lambda, 3 lambda. Okay, it depends upon
Yes.
the shape and nature of the wave being produced. Okay,
Yes, sir.
okay, and see next all these are, yes, again Muller's law, I is equal to I naught cos square of theta. We have done this with this thing. Okay, see next is nothing. Yes, it's about filament length. So filament is the filament, and the resistance of the filament decrease. Sorry, increase when the more temperature go through from it. Okay. Yes, here is drift speed. So simply for drift speed, you will use the formula S is equal to VT. Okay. Here is again potential difference across a specific
Yes.
resistor, and you will use this formula which we have repeated previously. P is equal to SES, mean the resistance across that resistor, and E is the electromotive force, and in denominator you will add up these two things. One thing that you could use potential divider to compare the electromotive force, and for that you will use this relation: E over V will be equal to L over small l. Mean this is electric motive force, and here you have total length, and this is the V for potential difference across a specific resistor or wire. Then you will take the length of that wire. Okay, so this is the this is
Yes.
relationship to make comparisons, or whenever you have lengths, two lengths or three lengths, and you are to find the potential difference or electric motive force, then you can use this relation. Okay.
Yes, sir.
And by the way, in this figure, like you can use this question where the wire has some length. Okay,
Yes, sir.
okay. See next. Yes, here you can see. In this question here you have this that relation. Okay, see next. Next is again alpha decay and beta decay. Okay, we have done this thing and repeated it. Okay, quarks and anti-quarks. So I think nothing was new in this paper. Now we are going to next paper. First question is same about base quantities and derived quantities. Okay. Second question is about percentage uncertainties. Okay. And third question is about absolute uncertainty. So for absolute uncertainty, you will just multiply the percentage uncertainty with that value of that equation and that quantity. Okay.
Yes, sir.
Okay. And here again, you have to use uh, laws of motion, that stress, strain, Hooke's law, Young's modulus. So all these are which we have discussed here. Below here you will use S is equal to VT and potential energy is equal to P is equal to mgh. Okay. One thing. Now I have got that efficiency. What is efficiency?
Useful over total times by
Yes,
100.
yes, useful over total or simply output over input times 100. Okay,
Yes.
okay. Here again you will use law of conservation of I have remembered one thing. What are the conditions for equilibrium?
You have zero resultant force and zero moment.
Yes, sum of forces should be zero for linear equilibrium. This is for linear equilibrium mean no linear acceleration, like no linear acceleration, and it is related with linear motion. Okay, and second is that what is second condition?
No resultant moment.
Yes, so let me call it torque or resultant moment, and it should be zero, and it is related with rotational motion. Okay, and when it is
Yeah.
satisfied, then though no angular acceleration. Meaning when this second one is satisfied, then no angular acceleration exists there. Okay,
Yes.
okay, and for a body to should be in complete agreement, these two conditions must be fulfilled. Okay, I see that downward movements are also equal to upward movements. Nothing new. Okay, then this is again from law of conservation of momentum, and kinetic energy is equal to half mv square. Momentum is equal to pmv. Okay, momentum before equal to momentum after. Next, again from change F is equal to change in momentum per unit time, which we have discussed earlier. Okay, here frequency is equal to 1 over t, reciprocal of time. Okay, here again slit and diffraction grating experiment. Again same formula, lambda is equal to ax over d. Okay. This is electric potential difference. What is electric potential difference? Because this definition have come more than 2 or 3 times in the past papers. What is electric potential difference?
Potential difference is the energy it's from it's from the batteries.
Yes, okay. And what is 1 volt? Volt.
1 volt
Oh, sorry,
is
not 1 ohm. 1 ohm. What is 1 ohm?
1 ohm is a volt per ampere.
Yes, volt per ampere, and it's fun unit of resistance. Okay,
Yes, sir.
okay. Here is again here you can use the relationship of electromotive force. Sorry, comparison of electric potentials. Me in form of lengths. So again here you will use this formula E is equal to L over small l and over V. Okay.
Yes, sir.
Okay. Now move next. Here is the Kirchhoff's current law, and second, and here is the electromotive force formula. Okay. Next is about again about decays, mean beta decay, beta positive decay, beta negative decay, and this is about fundamental particles. So, is there any difficulty in this paper?
No, sir.
So, this is paper 970222 paper, and for October November 2022. Okay. Now this again same for power. Power is equal to work done per unit time. Okay, and this question is about percentage uncertainties. Okay, next is about absolute uncertainty, nothing new. This is about tension, upthrust, and weight. We have discussed these things. Okay, and see next one. This is about equation of motion, which we have discussed earlier. V square is equal to u square plus 2as. Okay, nothing new. Center of mass. or center of gravity? What is center of mass and what is center of gravity?
Center of gravity is where all the weight acts upon on an
Okay, and
object.
center of mass.
Center of mass is where all the matter is stored.
Very good. Okay. Yeah, next is about yes, it's about stress. Stress is equal to force per unit area. Next is about again Hooke's law and kinetic energy. So, and elastic potential energy or strain energy is equal to half k x squared. Okay. Next is about change in momentum. Again, simple thing. Next is about force, which is equal to change in momentum per unit time. Nothing new. Okay. This is about stationary waves and wavelengths. Okay. This is the formula for wavelengths. Sorry, speed of wave, and you can use it for both for light and both for wave. Okay. This formula is
Yes.
equally applicable for light and wave. So when you are talking about light, then you will use the speed of light. Okay. And when you are talking about the sound, then you will use the speed of sound. And when you are talking about waves, then you will use the speed of that wave. Okay.
Yes.
Okay. See next. This again from Law's law, which is equal to the mean relationship between intensities. Okay, with angle which is called square theta. And next again potential difference. Again repeated question. Energy transfer per unit charge in a circuit. Okay, and this here is it's about potential differences and electromotive forces. We have also done this thing. This is about electromotive force, internal resistance, and potential difference. And this is about current. This is about this was new thing. Potential difference is equal to work done per unit time. Okay.
Yes, sir.
Here again, Kirchhoff first law, Kirchhoff second law, and electromotive force and its relationship with internal resistance. Next is about again decay. About decay, mean proton number, nucleon number, etc. So we have also discussed one thing. Here you should remember one thing, that 1 U is equal to this value 1.66, and charge on one electron is equal to 1.6 times 10 raised to the power minus 19, and similarly 1 electron volt is equal to 1.6 times 10 raised to the power minus 19 joule. Okay.
Yes.
Uh, okay, here again about the charge on particle, I mean up, down, and flavor about the particles. Okay.
Yes, sir.
ओके, तो फिर ऐसा है कि जैसा कि आप फिर हम एक और करेंगे कल ना, आप यानी फिजिक्स को देखना, अगर कोई और चीज आपने फिजिक्स की करनी हुई तो ठीक है, अदरवाइज हम फिर कल मैथ कर लेंगे, क्या ख्याल है?
नहीं सर, कल फिजिक्स कर लेते क्योंकि थर्सडे एग्जाम है।
अच्छा, तो फिर कल फिजिक्स का क्या करें? पास पेपर तो हमने कर लिए हैं, थ्योरी भी हमने डिस्कस कर ली हुई है।
मैं
चले
फिर से स्कूल
फिर
में करूँगा और
फिर,
फिर प्रॉब्लम
फिर
होगा मैं आपको कह दूंगा।
हाँ, ये करेंगे। आप ऐसा करना कि आप कल डे टाइम में उसको स्टडी करना, कोई भी प्रॉब्लम होना तो हम क्लास करेंगे, और उसमें आना, आप मुझसे वो पूछते जाना कि सर ये चीज़ क्या है, ये चीज़ है, जो जो भी आपको प्रॉब्लम है ना, हम जस्ट आपके प्रॉब्लम्स को डिस्कस करेंगे, ठीक हो गया ना?
हाँ सर।
सो दिस इज अबाउट अगेन बेस यूनिट्स, derived units, and next is about percentage uncertainties, absolute uncertainty. So until now I think you have got too much experience how to which type of paper questions are repeating in your exam.
यस सर।
Okay, so here is again about weight, force, and upthrust. Okay, this is about moment, vertical component of weight and horizontal component of weight when it is acting at some angle. Next is about upthrust, density. Huh, one thing, density is equal to mass per unit volume. Okay, now see next.
यस सर।
Yes, mg delta h, or potential energy is equal to mgh. Okay, this is Hooke's law again, elastic potential energy and Hooke's law. Okay, here, let's see here what is here. It's about equation of motions. Okay, Next, again, equation of motion. This is about acceleration. Next is about law of conservation of momentum before and after. Okay, this is about law of conservation of kinetic energy. Mean kinetic energy before collision equal to kinetic energy after collision. And this is about again diffraction grating experiment. Lambda is equal to ax over d. This is about order. Order mean potential path difference is equal to n lambda or d sine theta. Again, for related to path difference. Okay. Next is equal to
Yes,
again
sir.
again formula lambda is equal to ax over d. Okay, bright fringe, dark fringe, Ohm's law, this relationship for when the resistors are in series. So for series circuit, okay, for resistor to calculate when the resistors are in parallel, so you will use this one 1 over R is equal to 1 over R1 plus 1 over R2. Okay, again here potential difference across a specific resistance. Same formula you will use. V is equal to SE. S is the that specific resistance. S plus R. Okay, here
Yes.
again current. Okay, next about same all about uh, particles mean leptons, hadrons, beta decay, beta negative decay, beta positive decay, fundamental particles. Okay, so we have also done this thing. Is any question here?
No, sir.
ओके, तो अब हम क्या एंड करें या कुछ और क्वेश्चन है आपको? कोई और क्वेश्चन है तो आप पूछ लें, या कुछ और करना
नहीं
है तो?
समझ आ गया, अभी मैं फिर से पास पेपर कर लूँगा और फिर मैं
हाँ
देखूँगा।
चले, ये मैंने आपको सारे पास पेपर सेंड कर दिए थे ना, 21 तक में ख्याल
हाँ,
है मैंने आप। चले, तो आप ऐसा करें, पास पेपर्स को भी रिपीट करें और साथ में फर्स्ट पास पेपर को रिपीट करना है और उसके बाद आपने थ्योरी को रिपीट करना है, ठीक होगा ना? थ्योरी में भी आपने जस्ट ना वो जो उसकी समरी है, हर टॉपिक की जो समरी है वो आपने रिपीट करते जाना है, ठीक हो गया ना?
ठीक है सर।
ओके, एनी अदर क्वेश्चन?
ओके, नो क्वेश्चन।
देन बाय बाय।
बाय-बाय सर।